All right, so yesterday we talked about scalar versus vector quantities. Are there any vector quantities in this question? No, there's no direction given in anything here. So all of these are scalar, which means that this value here is what? Speed, right? Because speed is a scalar measure of how fast you are going. Okay, so that's v without the arrow over top, 15 meters per second. Okay, and it says 45 seconds. So time. Is time scalar or vector? Except that, as far as we know, is the only direction time moves. So as a result, time is scalar. Okay, time is treated as a scalar quantity. Okay, because we don't say, yeah, it's going to take you 5 hours left, or 5 hours. Well, sometimes we'd say 5 hours north, but that's one of our problems with how we communicate distance. Okay, in our society. So yeah, that's really, time is really not a vector quantity, because time really, as far as our experience goes. Okay, I mean, if you're into all the wormholes and space-time continuum and branching of multiverses and all that kind of stuff, time may not be as linear and scalar as we typically experience it. Okay, but for what we're doing, time is a scalar quantity because it's only going to travel forwards, unless you know something I don't. Okay, if you have a time machine at home, let's talk. Okay, all right. So 45 seconds is our time, and what is the question asking me to find? Distance. Anytime it says how far, that's distance. If it says how far and in what direction, then it's, which is, what's the vector version? Displacement. Okay, this is distance. How far is always distance. Okay, so that's the thing we're being asked to find. All right, so V equals d over t, and we're being asked to find d. So that means I have to move time, and to do that I have to do the opposite. So I would multiply, because right now I'm dividing by t. So t will cancel on that side. What I do to one side, I do to the other. And now I've got my formula for d. Everybody follow so far? Okay, so we'll take our 45 seconds, multiply it by 15. It comes out to 675 meters, is that right? Okay, 675 meters is how far the deer will run in 15 seconds at that speed. Okay, questions on how that works? Aiden.
If you're running 15 meters every second,
Yep.
there's 45 seconds.
Right, so if every second I go 15 meters, does that make sense? Right? I follow your reasoning. That's solid logic. If I'm running it going this far every second, 15 meters, and it's 45 seconds, that's 15 times 45. Oh, okay. All right. Try that one. A tortoise. I had originally started writing some other word when I made that up, and then I forgot what I was going to write, and I was like, I need a word that starts with T, and I need something really slow. And turtle, for some reason, didn't come to my mind. Tortoise did. I don't know. What do you do? When I edited stuff. Okay, so the at a speed of 0.15 meters per second. So same as when we're doing mole equation questions, you're going to get your first mark for writing down your givens, okay? Because that tells me you can interpret the question. So how long will it take? What am I being asked to find? Time. Anytime it asks how long, that's time. Okay, and it's to crawl 200 meters. That would be distance. How do I know it wasn't displacement? No direction, right? Okay, and at a speed, so they outright tell me it's speed, okay, of 0.15 meters per second. All right, so V equals d over t. Now I'm solving for t. How do I get t by itself? Sydney? Right, multiply both sides by t, because I can't solve for t when it's on the bottom. Okay, although I did have someone say yesterday, Mr. Coder, couldn't I just do this? Could I divide both sides by d and then reciprocate both sides? And the answer is yes, because according to the rules of algebra, as long as you do it, whatever you do to both sides, you can do whatever you want. Okay, and so that would work, because what I would have is v divided by d equals 1 over t. And then if I flip both sides, I've got the same formula I'm going to get by doing this. Okay, if I flip that, I still have the same thing. I have d over v equals t over 1, which is the same thing. Okay, so if you're more comfortable doing it that way, there's nothing mathematically wrong with reciprocating both sides afterwards. You can do it, it comes out with the same number. Okay, All right. So now that we've got our formula there, we're going to plug in our numbers. So time equals distance over speed. So that'll be our 200 meters divided by 0.15 meters per second. It's going to take quite a while. Okay. So 200 divided by 0.15. Okay, it's going to take 1,333 seconds. That's 22 minutes, yeah. Okay, so it's a long time to go 200 meters. Okay, so I would leave that as 1,333.3, repeating. Okay, sorry, seconds. Okay, is this starting to make some sense? A little bit, okay? I mean, the math isn't too tough, it's just moving things around, okay? I would advise that you get yourself a calculator in the near future, okay? Doesn't have to be a graphing calculator, it can just be a cheap scientific calculator. It doesn't need to be scientific because you gotta be able to take square roots and stuff with it, okay? And do exponents and things like that. So if you can get yourself one in the next little while, that would be good, because obviously, again, on the unit exam, you can't use your phone, okay, as a calculator. All right, this is the one we did yesterday. Okay, so things to remember. Scalar quantities have magnitude only. Okay, that is, they only have a measured value with units. So speed, okay, so like distance would be 65 kilometers. Mass, 75 kilograms. Mass is a scalar quantity. Okay, mass has no direction. It just tells people how much of you there is. Okay, the amount of matter that you possess is your mass. Okay, time is scalar, 4 days. Okay, vector quantities, magnitude and direction. So if it's displacement, it's like 20 kilometers north, okay, and things like that. So it's important to remember that vector quantities have both magnitude as well as direction. Okay, so they are a measured quantity with units with direction. Okay, and then the other thing, we talked about this yesterday as well, okay, that v equals d over t, speed is distance over time, okay, and that velocity is displacement over time. And for that one that we did in green yesterday, average velocity is total displacement over total time. And the same is true for speed. Average speed is total distance over total time. And that's what we need if our question has, or our problem has, more than one part. Okay? The two we just did, we're dealing with one part problems. There was this thing, it was going this fast for this long, how far did it go? Okay, that's simply a one-part question. But the one we did yesterday, okay, this one here with the bus, had 2 sections to the trip. Okay, so to find the average velocity over the whole trip, we found out its total displacement, its total time, and divided the 2. Everybody follow there? Okay. Okay, anyone need that one anymore? Okay, so before you get started on that, just want to quickly run through a couple more like kind of quick, easy examples. So a deer runs 100 meters in 20 seconds. How fast is it going? Is that about as easy as they get? Do I have to manipulate the formula? No, I'm given distance and time and asked to find speed. Okay, so our distance is 100 meters. Okay, the time is 20 seconds. Okay, we're looking for v. Well, v equals d over t. Okay, 100 divided by 20. Okay, gives us 5 meters per second. Okay, everybody all right with that? Okay, easy peasy on that one. Okay, and then we've done one like this. How long will it take a jet traveling at 330 meters per second to travel 400 kilometers? So, what's wrong with something given to me in this question? Not so much wrong, but what's going to give me trouble? Right, the units of measurement don't match. Okay, I'm given speed in meters per second, but I'm given distance in kilometers. I can't divide kilometers by meters per second. It's not going to work, okay, because one is 1,000 times bigger than the other. Everybody follow? So anytime a problem like this one comes up, you need to make your units match. Okay, which would be easier to convert? 300 meters per second to kilometers per second, or 400 kilometers to meters? Kilometers to meters, way easier. Okay, so how many meters are there in 400 kilometers? How many? Okay, that's how many meters are in 1 kilometer, so how many meters are in 400 kilometers? 400,000. Okay, so the distance traveled is 400,000 meters. Okay, and the speed is 300 meters per second. Right, we're looking for time. Okay, so V equals d over t. We multiply both sides by t, divide both sides by v. Okay, and we've got our new formula. So t is going to equal 400,000 divided by 300. Okay, and you can put the units in if you want. I don't always do it. I usually try to remember to do it, but I don't always. Sorry, 330, right. Because it's the speed of sound, actually. 330 meters per second is how fast sound travels. Okay, 400,000 divided by 330. Okay, so at the speed of sound, it would take 1,212 seconds, or 20 minutes, to travel 400 kilometers at the speed of sound. Okay. Most planes do not travel at exactly the speed of sound. Anybody know why? At exactly the speed of sound, it is actually a very inefficient speed to travel at. If you go a little bit faster than the speed of sound, it's way more efficient. Okay, a little bit slower, worse. Okay, and it's because of what happens to the air in front of a plane as it's getting close to the speed of sound. Okay, sound waves are a series of compressions and rarefactions of air. So as you travel close to the speed of sound, the sound you make travels the same speed you do. And so all the compressed air you're making as a result of all the sound waves pile up in front of the plane. Okay? So it builds up this wall of dense air in front of the plane, typically known as the sound barrier. Okay? This is where the term sound barrier came from. When they were first building planes to try and break the sound barrier, it looked like they ran into invisible walls in the sky when they reached the speed of sound and they blew up. Okay? It wasn't until they figured out how to puncture this wall of compressed air in front of the planes that they were able to make planes go faster than the speed of sound. So it's actually more efficient to go slightly faster than the speed of sound, because then all of your sound falls away behind you. Okay? Because it can't travel as fast as you're going. It's kind of weird. Okay? If a plane were to fly right over top of you, going way faster than the speed of sound, you wouldn't hear it right away. Okay? You wouldn't hear it approaching anyway. Once it traveled over top of you, you'd hear it. Okay? But you wouldn't hear it coming because it's traveling faster than the sound it's producing. Incidentally, that's also why there's an expression about not hearing the bullet that kills you. Okay? If you are shot by a sniper from long range, those bullets travel faster than the speed of sound. And as a result, you wouldn't hear it coming. Yeah. A little scary on that one. Good morning. Okay. A bird flies 650 meters north at a velocity of 9 meters per second north. How long is it flying? Okay. Is this a vector or scalar question? It's a vector question. Okay. It's a vector question asking us to solve for a scalar quantity, oddly enough, but it's still got vector quantities in it. So our velocity here is 9.0 meters per second north. Not really, no, unless you can go backwards in time. So unless you have a DeLorean at home that has like Mr. Fusion and a flux capacitor, you're probably not going to make that happen. Although I listened to an interesting podcast the other day. Neil, you guys know who Neil deGrasse Tyson is? He does Star Talk. Yeah, you should listen to that. He had one on time travel and parallel universes, which was actually quite interesting. If you get a chance, it's worth listening to. Okay, 650 meters, and we're looking for the time here. Okay, so V equals D over T, same calculation we just did a minute ago. T equals D over V, so we're going to have our 650 divided by 9. Okay, so 72.2 seconds. Okay, now here's why time ends up being scalar. This is meters north, this is meters per second north. Meters cancel. Norths cancel. I got north, top, and bottom. Okay, mathematically that kind of makes it cancel. Okay, so time ends up not having a direction. Okay, questions on how that one worked? Mathematically, it isn't any different than the ones we've done.
Oh, does that say 72?
72.2, yeah. Okay, I want you guys to try this one. Before I do it, I want you guys to give it a try. Okay, so the elevator travels up 85 meters. So let's say that this is ground level right here. Right, goes 85 meters up and then travels 60 meters down. Now this 85 meters takes 30 seconds. Then it travels down 60 meters and that takes 20 seconds. All right, if I want to find the average speed, what two things do I need? Distance and time. I need in particular the total distance and total time for this trip, right? Well, he went 85 and then 60. That means 145 meters, agreed? Okay, so the total distance traveled, okay? So average speed is total distance over total time. Okay, so that's going to be 85 plus 60 over 30 plus 20. Okay, that way I've calculated the total distance and the total time. Right, so 145 over 50, 145 meters over 50 seconds. Okay, so 145 divided by 50 gives me 2.9 meters per second. Okay, how is what I do to solve part B different? Displacement, right? I need total displacement. The total time is still the same. This trip took 50 seconds. Okay, that part's not going to change. But what does change is now I'm only worried about how far from the starting position did I end up and in what direction. Okay, so they went 85 up and now 60 down. So they ended up how far from where they started? 25 meters up from where they started. Okay, their total displacement here is 25 meters up. That's why I drew the diagram this way. When we get to physics 20, we always represent vector quantities with arrows. The length of the arrow represents their magnitude, which is why my 85 meter line is longer than my 60 meter line. Okay, and the direction the arrow points represents the direction traveled, up and down in this case. Okay, what we usually do then is draw them tail to head. So instead of drawing it side by side, I would draw them right on top of each other, okay, showing that, hey, it ends up directly above where it started. Everybody follow there? Okay. Okay, just for simplicity's sake, I have it kind of drawn that way. Okay, so to calculate the average velocity, I'm going to take my total displacement, so the arrow over top this time, okay, over total time. So that's going to mean positive 85 meters plus negative 60 meters. When we're dealing with vector quantities, you're going to have to assign a positive and negative value. Okay, we call this vector addition. That's why I put a plus sign in there. Okay, it's not vector subtraction. Okay, I mean, I could just say minus 60. Mathematically, it'll give me the same answer. Okay, and then on this side here, it'll still be 30 plus 20. Right, so now I'm going to end up with positive 25 meters on the top over 50 seconds on the bottom, which is going to give me an average velocity of 0.5 meters per second up. How important is it for me to put the up on that answer? If you want to get a mark, important. You forget the up, it's not velocity. It's what? Well, actually, it's not speed either, because that's not the right number for speed. I don't know what it is. It isn't the right answer if it doesn't have a vector on it, is, I guess, the bottom line. Okay, make sure all your vector quantities have vectors on the answer. Okay, and really that's, I mean, other than making a trip have more parts, like up to 3 or 4 parts, they don't really get any more difficult than that. Okay, the method is still the same. You got to find the distance or the displacement in each section and add them all together, okay, in order to get the final number. Okay, questions on that? It's an arrow. Yeah, it's an arrow with only one side on it. It's how mathematically we represent this is a vector quantity. So it's saying this has a direction. Yeah. Okay. All right. Once you're working on that worksheet, the answers are on there. Okay. So you'll know if you did them right or not. Not the solutions, just the answer. Okay. So you can start working on those. Pay attention to whether it's asking you for a scalar or a vector quantity when you do the question, because oftentimes we get the wrong answer. It's because we solved it as a scalar when it was actually a vector, or vice versa.
So when you said the answers, you mean the answer to
Yeah, what I mean by solution would be like a step-by-step. How did I solve this? That's just the answer. That's what, yeah, you guys can solve it and then see if you get the same answer I did, right? Yeah, so sorry guys, in physics, we solution and answer are two different things. Solution is the method used to arrive at the answer, okay? So all I've put on there is the answer, okay? All right, so the world record of 274 meters per second for the fastest jet engine car has the following measurements. The driver makes 2 runs, okay, through the course, 1 in each direction. The car first travels from left to right and covers a distance of 604 meters in 2.19 seconds. So D equals 604, and that's displacement, because they did tell me it was from left to right, and he does that in a time of 2.19 seconds. Okay, the car then reverses direction and covers the same distance in 2.22 seconds. Okay, and I'm just going to write on here right and left, even though I have the arrows there. Okay, time equals 2.22 seconds. Now, to get the world record, you actually average the 2 runs, but the question is asking, determine the average velocity for each run. So it's asking you to treat them separately. Everyone follow? Okay, because if I asked you to calculate the average velocity for the whole trip, what would it be? 0. He goes 604 meters to the right, and then he goes 604 meters to the left, and ends up right back where he started. His total displacement would, as a result, be 0, so his average velocity would be 0. Wouldn't be much point to doing that in a question because it wouldn't require any work. Okay, so in this case, it's just asking you to do 2 v equals d over t questions, okay, where it's velocity and displacement this time. So 604 over 2.19 gives us 276 meters per second right, because that's when he's going from left to right. And then this one would be v equals d over t for the other run, 604 meters left, okay, over 2.22 seconds, which gives us the 272 meters per second left. Okay, so it's kind of confusing. It's not worded very well. I think that's what gives people trouble with that one. Okay, any others? Okay, keep going then. So in this question, if I'm sitting in a plane on a runway and I'm looking out the window, okay, I kind of mark a spot on the window. And when I see the plane, the front of the plane past this point, I start timing, okay? I'm essentially, that's when the question is going to start, when the front of the plane is here. The question ends when the back of the plane passes that same point. In other words, the front of the plane has traveled the length of the plane in allowing the back of the plane to come past that same point. You guys follow me there? So what we're saying is the length of the plane is actually the distance the plane traveled, 36 meters. Okay, so if he traveled 36 meters at 45 meters per second, how long did it take?